Okay, let's go through the syllabus of this course CE2210 section 105 together. Okay, so first of all, you have known me. I'm the instructor, Hongyan Ma, and my email is here. So if you have any problem, any concerns, you can just drop me an email through the whole semester. Okay, apart from me, we will have a teaching assistant. It will be a grader, Farshad. His email is here, and he also has the office. So he will help to grade all of the homeworks and handle part of the office hours, perhaps. So if you have questions regarding homework problems, if you have any concerns, you can make your choice. You can send me an email or send an email to him. Okay, the class time is listed here, and some students have sent me email saying that they cannot find the class time. So our class time will be Tuesday, Thursday, 12:30 to 1:45. Well, these are the times for the synchronous sessions. So if you prefer asynchronous sessions options, well, you can just ignore the time and just watch our records in Canvas or watch the short videos that I will provide you in our handouts. Okay, the Zoom link will be the same through the whole semester. You can just keep using this one at the scheduled class times. Okay, use the meeting ID and the passcode if you're requested to provide a passcode. Then the office hour will be, this is just tentative office hours, will be Wednesday 2 to 30. It's up to change later. So I may give you different times, but you will receive email from me if I change it to another time. Okay, this office hour will also be handled on Zoom. So the link is here. This is different from the lecture link. Okay, you will have a different link and a different passcode. Oh, the course description. The mechanics of materials discusses the relations between stress and strain of deformable solid. So it applies analysis to members subjected to axial bending and torsional loads. So this course basically, in the beginning, like in the chapter 1, we will introduce stress and strain. So then we will talk about the basic properties of materials. So that is the correlation between these two things, stress and strain. And we will introduce the basic concept of design. So after that, we will start to talk about the stress analysis in axially loaded elements. Those are just the like a bars, okay, like a bar. So these are called axially loaded elements. In chapter 4, we will talk about bending moment. Those are just circular shafts. Okay, when you bend a circular shaft, how do you analyze the stress and the deformation of it? Then after that, we will have a big thing that is beam, the bending moment, bending elements. Okay, in chapters 5, 6, and 7, we will talk about the beams, bending, deflection, and shear. Okay, then we will talk about combined loading. We will talk about generalized Hooke's law, pressurized vessel, etc. That is the basic structure of our mechanics of materials. So you can read the detailed objectives here, so I will not go through them word by word. And the prerequisite of this course is statics. I believe all of you have finished, graduated from CE2210, and get a grade of C or better. So that is our prerequisite. Okay, the statics, through statics, you should have understood the free body diagram and how to write equilibrium equations and use them to solve the internal forces. Okay, so here in mechanics and materials, we will talk about internal forces. Internal forces leads to stresses, and then we'll have strains. So stress and strain are basically the core topics of mechanics and materials. So you have to know how to determine internal forces. Otherwise, you cannot solve any problems here in this course. Then you should know how to draw shear and moment diagrams. Those are very critical in chapters 5, 6, and 7 when we talk about beams. Okay, the main learning resources are my resources. Okay, are the class lectures and in-class activities throughout the semester in class. In this semester, those will be in the synchronous sessions. If you select asynchronous sessions, there will be no in-class activities, but we will have in-class assessment. And if you're asynchronous, I will give you options too. You will have your own options, and we will upload. I will publish the in-class assignments on Canvas, so that you will get basically a whole day to solve them and upload your solution to it to get grades. Okay. Then we have course modules in Canvas, and we'll have instructional videos, as I mentioned. Apart from the recorded Zoom lectures, I will produce some short videos. So basically, one short video is just introduction to a basic theory or a single example, detailed example. So I will just cut them into short videos, then embed them in my handout, in my slides. I will upload them to Canvas. You can download them. So when you review the materials, you can click the links to watch my short videos on YouTube. Okay, so apart from that, we have supplementary materials and resources. The first one is the Mac movies by Dr. Philpott, and the second one is another website created by Dr. Jeff Thomas. Okay, those are our prior instructors of mechanics materials. Then I will also provide you some links produced by Nick Libre. So you know Nick Libre is producing a lot of videos, and he used it for preview purposes in his two big sections. Okay, some of them, most of them are very good videos, while just for illustrations of basic theories or detailed examples, etc. I may select part of them and share the links with you, and you can also click them and to learn basic theories from those short videos. Some of you may know that Nick has a public YouTube channel. So if you need more learning resources, go there. Just go to YouTube, search Nick Libre Mechanics Materials. Okay, so you will get the channel of Dr. Libre's, and you can find a lot of hundreds of short videos there. Then in addition, any of the following textbooks provide a resource for studying. I just give two reference books. So we don't have any mandatory textbook, but it always be helpful to use a book as a reference, so you can find more problems to solve and longer versions of explanations of these theories, etc., and how to derive equations in the textbooks. If you're very theoretical, if you want to learn more about the theories, just I really recommend these two textbooks. Then later you can see COVID-19 information. Those are mandatory in the syllabus of this semester. So the first one, I think you have read them several times. It's requiring that everyone has to wear a cloth mask, a face covering in classrooms and common areas. So we don't have this option, so I'm not wearing any face covering now. So we don't have these limitations. But need to keep this in mind if you attend other classes on campus, if you're going to anywhere in the campus, so you have to wear a face covering. And number two, if I become ill, the classes may be moved fully to asynchronous, so you will always receive my handout with embedded links. Okay, in worst cases, you know what that means, right? It's the instructor room. I will have two stops. These are the other instructors of mechanics materials. Could be Jenny Liu, could be Nick Libre. Then if you become ill or unable to attend the class or take tests on campus due to some specific reasons, please let me know as soon as possible, especially if you're not coming back to campus in the whole semester. And you may need to work with the testing center to arrange some special time sessions or other things to get the tests done on time properly. Okay, the course learning model. You know that Dr. Libre is giving kind of active learning model. Right? It's per his definition, my model is kind of traditional model. So basically, I will talk about the theories and give you detailed examples during the class time, and you may review them and then do your exercises after the class, and you have to solve the homework problems so that you can learn the whole thing. Okay, this is a traditional model, but I do recommend you to use some active learning model. So I have provided the preview versions of the handout, the slides. So you should have seen that I have uploaded a preview version of my slides. That is the handout. Okay, in files, in Canvas files, chapter 1. Okay, you can download a preview version of the slides, and later I will have updates. Okay, I will have updated lecture 1, lecture 2, etc. Okay, you should have preview before the lecture time, and then follow me to do some in-class activities if we have enough synchronous students there. Then do the in-class assessments. We will have a lot of in-class assessments, as I mentioned. I will basically publish them in Canvas, in assignments. So you have one day, 23 hours perhaps, to work out them and upload them to get grade. Okay, I will select the core concepts and the core methods involved in a class and make them in design the in-class assessments based on them. So if you want to do the homeworks, very likely you need to understand these core concepts well, so that you can work out the homework problems well. The after-class homework, the homework will be assigned through the semester and can be accessed on Canvas. Okay, I will give you deadlines to submit the homeworks. If you have trouble meeting those deadlines, do let me know as early as possible. Okay, otherwise you may get deduction in the grades. Grading policy, this is very critical. As you can see here, your final grades will consist of several parts. The first of all, of course, will be the assignments. We'll have in-class assignments, as I mentioned. You will have after-class homeworks. They will take a percentage of 10% and 15% respectively towards your final grades. Then we'll have 4 midterm exams. 4, yeah, that's correct. 4 midterm exams. We will have a midterm exam every 4 weeks, every 3-4 weeks. Okay, so we will go through later. Then the 4 midterm exams will be, your grades will be averaged, and that will take a percentage of 45 towards your final grades. We will have a final exam in the final exam week, and your grade will take 30%. Okay, adding these 4 parts together, that is 100%. And apart from that, we'll have bonus points. The maximum possibility of bonus point is 7 point. That is to say, our total grades will be 107. Okay, so we will have bonus homeworks. That is the majority of the bonus points source. So if you submit the bonus homeworks on time and get graded, so you will have a possibility to get all of those bonus points. This is very critical for students pursuing high grades, high final grades. For example, you get 84 out of the top 4 parts, right? Out of the in-class assessment, homework, for midterm exams and final exam, you get 84. And you submitted all the bonus homeworks, and you get 6 or 7 bonus points. Then you will be able to get an A. Okay, that is this is what bonus points mean here towards your final exam, towards your final grades. Okay, the table 1 give a tentative syllabus and course topics. As you can see here, we have so many weeks in this semester. So in the first 3 weeks, we will cover the introduction to stress and strain, the mechanical properties of materials, basic design concepts, and axially loaded members, the chapters 1, 2, 3. And these 3 chapters will be covered in the first midterm exam that will happen on Wednesday of the week 4. Okay, the time has been confirmed, and it will be 5 to 6:30 p.m. Okay, I cannot tell where we will take the midterm exam, especially the first one. So tentatively, Dr. Libri has booked gym or the Leach Theater. I'm not sure. We may have physical tests. Okay, you may need to sit in a big classroom to have the midterm exam done. But I cannot say that. Perhaps this will be changed, and all of the testing sessions will be moved online. So you will receive email later. Okay, we will have discussions. We will have instructors meetings, and make a final decision how we will handle the midterm and the final exams. Then in the second stage, we will talk about chapter 4, that will be torsional elements, and then bending of beams. These are chapter 4 and 5. These 2 chapters will be covered in the second midterm exam. Then in this period, you can see we have 2 special days. The first one will be September 22. So that will be the career fair. Obviously, we will not cancel the class on that day. So very likely we will not have synchronous students on that day. So we may only have asynchronous options on that day. And the other one would be the fall break. So we will miss 1 class on that Thursday. Okay, but we miss that class, meaning that we will not have synchronous sessions. So, but we may have. I will have to upload a handouts with embedded short videos, because normally I fall behind Dr. Libri. My progress is always much slower than his, because his active learning style is very time saving. I am traditional, so I talk about all theories during the class time, so I'm always slower than him. So if we have a need, we have that demand to catch up with him, with his progress, I will leverage that missed class. Okay. Then later in the third stage, we will cover beam deflection and shear. Okay, that will be in the second midterm exam. Then later we will talk about generalized Hooke's law, pressurized vessel, and combined loading. Okay, so those are all of the topics that will be covered in mechanics and materials. The class attendance will not be a problem, since we have in-class assessments or in-class assignments, which is no matter what you call it. Basically, in the previous semesters, I used this tool to record attendance. Okay, but in this semester, we don't have that problem. So, but it's still very important. To get your attendance recorded, is submit your in-class assignment on time. That's within 23 hours after each of our synchronous sessions. And the email communication will be also critical. The emails could be used to set appointment with me, reporting mistakes on the handouts, provide feedbacks or suggestions, and general communications regarding your special requirements, etc. Okay, so yeah, I will try my best to reply your email in a timely manner. Sometimes it will have some delay. But email will always be a very useful tool for my session, right? So when you have any questions regarding anything, just send me email, okay? Class problems, special arrangement, change of any plan, etc. Just send me email. And the office hour has been introduced. Our office hour will be there, so we'll have our office hours also on Zoom. But the time is up to change. With exams, exams have been arranged. The time has been arranged, but how we will handle it has not been confirmed yet. So wait for my further email. If you have special needs, like extended time session, like requirements of a different time session, is let me know as early as possible, and let the testing center know. So you should make a special arrangement through testing center. Okay, read more details about yourself. Homeworks. Then the path to success. Okay, this is a fundamental course. Mechanics and materials is a fundamental course in many engineering disciplines. So that is why my section have students from basically all departments in engineering. Have civil students, mechanical engineering, ceramic engineering, metallurgy, and geoscience, etc. I can see students from all departments. Okay, this is fundamental course in many disciplines. It provides a foundation based on which all design courses are established. Therefore, it's very important to understand all topics presented in this course before you select the design courses. That is why CE2210 is a prerequisite of a lot of senior design courses. Okay. What does that mean? This means this semester, this contents will be tough. A lot of students told me in previous semesters, I have a lot of students told me that I heard that mechanics materials is super tough. I said, no worries, but that is true. Okay, to most of the students, this is a very tough course. You will be stressed out. Okay, you will be stressed out. So just how to succeed, right? How to be successful. How to be successful in this mechanics materials. I have provided the path here. So first of all, be prepared. Okay, first of all, be prepared to have a tough semester, to have a tough course. And second, be prepared before any class. Okay, do your preview and maybe use Dr. Libre's links, preview materials to get familiar with all of the topics before attending any synchronous session. Then participate in class activities. In our session, this means try your best to do the in-class assignments. As I mentioned, these in-class assignments will be designed based on the core concepts or core methods in the current topic. Okay, just try your best to finish the in-class assignments on time. Then fully use the learning resources. As I mentioned, apart from my learning resources, I have also provided you resources from the previous instructors, from Dr. Libre, etc. Fully use them. And do the assignment on time and do the exercises. Okay, we will have homeworks. We will have, in my classes, I will talk about theories. I will go through many detailed examples, but that not all needed. You need to be successful. So I will give you pretty many after class exercises where you can do more exercises apart from our in-class examples. Those will be the minimum problems you should try, but that is also the minimum sources that make sure you can get a satisfactory grades. But if you want to become a master of solving mechanics problems, you have to try more. Okay, even more than the in-class examples, more than the after-class exercises. So you should extend your learning to the textbooks, to the other learning resources of mechanics materials. Then ask for help. Okay, this is always useful when you have problems, technical problems, in class examples, in after class exercises. Always ask for help. Ask for help from your peers, from your classmates, from me, from the TA. I always ask for help. So do not keep the problems to final exams. Time arrangement. This is just to say you need to spend a lot of time. Okay, you need to spend a lot of time. As I mentioned, be prepared to be stressed out through the whole semester. Okay, plan to spend 6 to 10 hours per week on reviewing the lectures and do exercises. Okay, these are more. These are all specific for this section 105. And then later you have more. We have more paragraphs. Those are common information for syllabus. I will not go through details. You can read them paragraph by paragraph, but I believe you have read them many times.